Welcome to the session. The topic of the session is AI/ML model deployment and MLOps in GCP. So let me get started. The outline of the session is that we have primarily three parts. First, we will discuss GCP and GCP services. Then we will discuss about model deployment. Then we will talk about MLOps and how to do it in how in the context of GCP. And these are the three main parts, but in the end we will also briefly touch upon deployment of LLMs and LLM ops. So that's the fourth part is just for the sake of completion, but primarily we will talk about the AML deployment in GCP, and particularly with respect to Vertex AI. So this session will be useful for you if you are trying to do any GCP ML engineering certification, or if you are trying to use GCP for your as your platform for you. For those purposes, this will be useful. So there will be primarily it's going to be on the MLOps side, and yeah. So I'm working as a data science lead, but I'm also learning more about MLOps because the role is now changing. As you know, with the AI, many things are changing, and one thing that is we observe is that the roles are like the stack is now collapsing, and then we are asked to look at roles that are adjacent to us. So primarily I was a data scientist, but now I'm also looking into MLOps. So primarily to change the role from say just as a data science to AI engineer. So for that purpose, I'm also learning MLOps. This is, as I said, this is for GCP, and we will go through this sequence where first we discuss GCP and GCP services first.
Just a quick note, Analytics Vidhya has 100 plus free courses from beginner to advanced on topics like machine learning, generative AI, agents, etc. Complete with certification. Click the I button to explore now.
Yeah, so as you all know, GCP is one of the cloud services, popular cloud services, along with the AWS and Azure. So it provides infrastructure as a service and platform as a service offerings for compute, storage, databases, network, etc. If you compare it with the AWS and Azure, Google Cloud has a global infrastructure. It is spread across globally in 40 regions, 40 plus regions. And so we can be guaranteed of lower latency for our applications because it's globally spread. Um, and If you compare it with the AWS and Azure, the market share for GCP is around 12%. But GCP has certain advantages when it comes to AI/ML workloads. It has a very good offering for AI/ML, AI and machine learning. Even recently, whatever we see, there are a lot of very interesting things happening with respect to in GCP. Primarily, Vertex AI is one offering that we will go into it a little bit depth in this session. Also, there's advantages with respect to pricing when it comes to GCP, because they have a different kind of pricing. So which is has a discount attached to it. So if you are using a particular resources more in a particular month, so you will get some kind of discount. So that's called a sustained usage discount. So there are some kind of advantages with respect to pricing. So we get some automatic savings for GCP. Coming to so everybody can try out GCP. There is $300 credit worth of credit for 90 days. So I'm using that tier only. So I'm not paying for for that. But whenever I use it, I actually burn whatever the credit that's available for me. But for learning purposes, we can definitely use this free tier that is available in GCP. That's available to everybody. So carbon footprint. So GCP is comparatively to others was the first one to go carbon neutral. So the carbon footprint of that infrastructure was carbon neutral since 2007. AWS compared to AWS and Azure, 2007 GCP went carbon neutral, and they have a target to be carbon free by 2030. Yeah, so that's a overall introduction to GCP. So GCP has got many offerings that are available. So if you put all the GCP services, there are around like 200 plus GCP services are available, but you can put them in around 8 buckets. You can put them. So you have compute storage network, that's basic. Then AI machine learning, and for big data analytics, there are few services available. Then for multi-cloud, there are few services, and then developer tools and security and identity. So these buckets like cover all the services. It is not necessary for us to know all the services that are there, but few important ones we need to know. For data science, there is this diagram where it lists out like what are all the services that can be used for each stage of the data science development. So for ingestion, you can use data flow, data proc for data pre-processing, and then cloud storage for data storage. And then for data exploration, data pre-processing, feature engineering. For every step of the data science pipeline, we have GCP services available. And if you see, this diagram has around 40 services. So if we know all these 40 services, we can be comfortably work on data science. And most of the services, if you see a little bit, it's all related to Vertex AI Workbench, Vertex AI Training, Vertex AI Feature Store. All the Vertex AI Prediction, there are a lot of services that are specific to Vertex AI. We will see Vertex AI in a lot more detail in the coming slides. Yeah, so like I said, it is not necessary for us to know all the services, but a few essential services. I just wanted to give a brief intro, just few services for us to have a basic understanding that everybody has to know, so that we can relate to that when in the subsequent part of this presentation. So coming to the essential services to know, on the compute side, we have these three services: Google Compute Engine, Cloud Run, and Cloud Functions. So GCE is like a it provides us virtual machines for us. So it abstracts the virtual machines and gives us it as a service for us. So it is very useful for us to use GCE when we want to have control over like what kind of machines that we run on. Suppose that we want to run on say a specific GPU or a specific CPU. So those kinds of granular control, if you need it, then you can go for GCE. For those familiar with AWS, I think the equivalent for GCE is the EC2 instance. And GCE has this capability to do have auto scaling, and so suppose that a node fails, it has auto healing, and all these features are available. So that is GCE. So the other service is Cloud Run. So Cloud Run, it is like AWS Fargate, where you can deploy and run a containerized application. So it is fully managed. So here you do not have control about like what kind of machine the particular application is running on. But this is useful when you don't have to worry about that. So this is for Cloud Run, where you can run your containerized applications. Then Cloud Functions. Cloud Functions is a function as a service. Function as a service meaning that you can run like single functions on the cloud. It is like AWS Lambda, and so it is useful for event-driven automation. Suppose that you have a GCS bucket, and once a file is deposited into the GCS bucket, you want to trigger a task, right? So those kinds of automation that you want to do for event-driven automation, you can use cloud functions. In compute, we also want to understand two more. Two more is Google Kubernetes Engine and App Engine. Google Kubernetes Engine is again a fully managed service, but for Kubernetes there is a control plane and there are worker nodes. So the control plane is managed by it's managed service. It is provided by GCP, and so it is, you can use it to deploy Dockerized applications. So we will see how to deploy a Dockerized model application in the coming slides. Similarly, there is App Engine. App Engine is this is a fully managed serverless platform. So serverless meaning that we don't dictate like what server instances it is running on. That is entirely taken care of by the managed service. If you want to develop a web application and you just want to focus on the code and you do not worry about on which machine it is running on, for those kinds of scenarios you can use App Engine. So that is for compute. For network, I think we need to understand VPC and load balancers. VPC is when you want to have a private network, virtual private network. So you normally, for your application, you will set up a VPC and then you will set it to your firewall rules, subnets, and all these things you will configure. So that is the VPC, virtual private cloud. And normally you will have a load balancer inside your virtual private cloud to kind of like divert the traffic, so that the traffic is equally distributed among the servers. Suppose that one server goes down, the load balancer makes sure that the traffic is reaching the available servers, so that you get available service. So automatic failover, auto scaling. So those are some of the features that load balancers provide. So that's for network. For storage, at least we should know the GCS bucket and BigQuery tables. GCS bucket is a fully managed object storage where you have a bucket name that is like globally it is like a unique name across all projects, and you can store anything on this GCS bucket. So you can use it like a data lake where you can write any kind of data, text or image or any kind of data. So there are different storage classes for GCS. You have standard, nearline, cold line, and archive. Archive is when you have data that you do not access frequently. So the cost for it is low, but the latency is high. But for the normal ones, if you want to frequently access data, you will go with the standard storage class where you have low latency access. Then there is BigQuery tables, or where you write SQL, you run SQL queries on petabytes of data. It supports big data analytics. So that is BigQuery tables are like very useful for doing data analytics and having your data, large data. So that's the two essential services that we need to know. And finally, we talked about Vertex AI. Vertex AI is a unified platform with all the machine learning tools. If you see this diagram here, so it has a lot of Vertex AI components. You have for Vertex AI experiment, Vertex AI training, deployment, model monitoring, experiments, pipelines, etc. So Vertex AI is one of the core things that we need for MLOps. So it's a single managed environment for streamlining the entire ML lifecycle. So in addition to Vertex AI, there are a few other things that are offered in GCP. There are some AutoML specific services which gives you like off-the-shelf components for you, like say for doing automated machine learning. Then you also have AI platform again for experienced data scientists. They can train and deploy models. There's two more services, but yeah, Vertex AI is primarily for MLOps, which we will talk more about it. Yeah. So those are some of the essential services. Now we will get into the part where we get into the model deployment. So if we talk about model deployment, right? So there are different kinds of model deployment. The two primary things that normally we talk about is the real-time and batch deployment. In addition to that, there is also something like edge deployment. Sometimes you deploy the models on the edge, where the amount of resources is very low. So those things are also there. But I think primarily most of the time we use these kinds of real-time and on batch prediction. So online prediction or real-time prediction is when you do your prediction on some request that is coming. So you have a request JSON, you hit an endpoint, and then you get the prediction. So that is the online prediction. Batch prediction is when you have a batch of data, like the name says, you have a batch of data, and for all of the data, you run a prediction and get output. So for example, in the say for the online prediction, right? Suppose that you have a you're trying to predict fraud. Somebody is swiping their credit card, and at that point in time, you want to predict if this particular transaction is fraud or not. So this falls into the category of online prediction, because while they swipe the card, you have to make the request to the prediction service, and like get the prediction whether it is a fraud or not fraud. So this falls into the category of online prediction. As you can see here, latency is very important, because if it is taking a long time to do the prediction and return back, so that's not going to be a good experience for the customer. So latency, online prediction is primarily latency driven. For batch prediction, the use case is that suppose that you want to generate risk score for your customers. Suppose that you want to find risk score for whether they can uh, for risk, say fraud, say financial credit risk score, like in the financial space. So for all of your customers, you will generate credit risk score, and you will be doing it in a predefined cadence. So you for every day at a particular time, you will run this batch process where you take all of your customers, and then you based on the recent data, you will create a risk score. So this is batch deployment. So you can see like both of them are two different types, and for this particular presentation, we will focus more on the online prediction, where we deploy an application and we hit the endpoint, and then we get a prediction. So that's what you will see. Now, there are different ways to actually deploy in the cloud. So, say that, so it depends on like what all you want to do, right? So, say the normal one, the widely held like mini tutorials, they have this thing like whether you like how you can deploy is that you create a pickle file, and then you wrap the predict for that particular pickle file in a Flask web application, and then that particular web application you deploy it, right? So and that would expose an API, and when you hit that API, you get a response. So this is a simple way of deployment that many tutorials they address this thing. In this case, you are not training it on the cloud. You are just already you have created a pickle file locally, and then you are just only using you are only like uploading to the cloud the pickle file or the Mojo file to the cloud, and then you are just only doing the prediction or the inference. So this is one way of deployment, which we all do. I mean, even in our company, we do this kind of deployment. We do. But there is but there's in a real scenario, so you will probably want to do more, right? So you can't just only do pickle based deployment. You also have feature engineering, which you have to deploy the feature engineering pipeline. If you have any pre-processing, that also you have to do, and if you have any ingestion in the ETL pipeline, that also you have to deploy. So in the real scenario, what you want to deploy is you want to deploy pipelines rather than just a pickle file. So that is using the Vertex AI pipeline, which we will see later. But for the sake of discussion, we will also start with the simple one, where we flask the application and deploy. And when we talk about deployment, we saw that we have different compute services available. You can either deploy it on an app engine, or you can deploy it, say, on a cloud function, or you can say Dockerize and deploy it on Kubernetes. So we will just see the 1 and 3, how to do this. So how to do this deployment, deployment. So for the demo, right? So I actually can't demo the whole. I can't do a live demo because it takes time, right? So what I will do is I'll just simulate the steps that are required, and then I will run through the code and simulate the steps that are required, and then show the output. So that's how I will show the demo. So okay, so let's see what are the chat. Is anything there? Nothing. Okay. Let's go into that. For the first deploying using App Engine, what we want to see is, what we want to do here is, we have a application that has been like created using Flask, and we want to deploy this application in GCP. So the application is quite simple. I will show the application. It is the starter. It is a starter application for any machine learning, the iris classification problem, where this is the simplest scenario, where you guys would know this particular problem, right? So you have the sepal length and width, sepal and petal length width, and you have to predict the flower species, right? So that's the problem. And if you see, there are 3 files here, where the train.py file, it is going to load the data and then do a train test bed, fit a logistic regression model, and after training the model, it is writing it to a pickle file. In the predict, there is a function that is there, which takes the input, and then it does a dot predict and get the predictions. And in the main, here we do this wrapping with the Flask, wrapping it as a Flask application, where we are exposing the endpoint slash predict, and then we have and we just make the call to this particular make prediction to get it, and then return it to the caller. Okay, so this particular application, we will try to deploy it using the app engine. So this will require an app.yaml file. In the app.yaml file, what you will specify is that what is the runtime that you have to use. Here I'm saying that it will use Python 3.9 runtime. That's the only thing that I have given here. But probably you might also have to, when you are doing it, you also need to say a few more things, like CPU, number of CPUs, like that. You can have additional configuration, but for our case, this is enough. Now, so with this, if you want to deploy it into GCP, it just requires only one single line of command. You just have to say gcloud deploy, app deploy. So that is going to deploy into the app engine. So this is my console, Google console, where I have my Google console here. So for each of this, I'll create a project. Okay, so for project is, you have an organization, then within the organization you have multiple projects, and for this particular iris classification, there is a project that I have created. And so what we need to do is that we have to clone this repo of code into it, and then wherever that our app.yaml is located, we have to get into that, and then we have to run that particular gcloud app deploy. Okay, so yeah, even for connecting, it is taking time. Okay, so what I needed to show here was that you get into the console, you have to run that. You get into that particular folder and then run this particular command. One command, gcloud app deploy. Once this particular command will you look at the app.yaml file and then deploy it onto the app engine. So, and it will give you an URL, like which URL it deployed. So this URL you can hit it on Postman and see like whether you are getting the predicted output. Yeah, so you are getting the predicted output. So that's the deployment with respect to the app engine. So very easy deployment. Okay, so you have to, yeah, you go into this. I have cloned this particular code, and you have this app.yaml here. And yeah, so in the original repo there's a few in requirements.txt I made a few changes, and I have shared the modified requirement.txt, so you can try this on your end. So in this folder you have to get to this folder, and then you have to run this particular command. So that is going to app deploy. So if I say gcloud app versions list, let's see what's showing. So it shows like what is the default apps that are already deployed. Okay, so this is the app engine deployment. Then the next is to deploying using Kubernetes. So that was a easy one. So normally what we will do is that we have an Flask based application. So so in the first case, the app engine actually took care of all the details. So it took care of when you specify the runtime, it took care of all the details of converting into containers and deploying it. Everything it took care of it. But if you want to do it on our own, we can also do it. So this is a second example where I have a stroke prediction problem where we are trying to predict whether for a particular record, whether that particular person is likely to get a stroke or not. Okay, so that is, so if you see this repo code. So we have data where what is the age of this particular person, and then whether this person has got hypertension or BMI. So there are some features that are like this, and we create a pipeline to train it. So here is where we do the training, where we get the numerical columns, categorical columns. It's a simple code where you just convert it to categorical variables and then pass it to your model training. There's a pre-processing, and then model training is just fitting a decision tree classifier. So after fitting the decision tree, you again like dump that particular trained model. Now this also has a Docker file. Okay, so in this Docker file, what we have is that we have a base image where it's based on Python 3.10. We have one base image. From that, we are using this GUnicorn. We are starting this GUnicorn web server. I exposed at 5,000, so 500. So this is what we actually like have the Docker file. So when we run this, so the steps that are required. First, you have to create the Docker image, and then push it to gcr.io. So what we have to do is that, so in this particular thing, here you have to change the current project. Here the current project, I think it is set to current project is GCP deployment. So now what we have to do is we have to change the current project. And then we have to go into stroke prediction, this code. So here you have all this you have all this Docker file and images, everything. You have to run these commands first. Docker build and Docker push you have to do first. Then after when these two steps are done, your Docker file will go into the gcr.io remote Docker registry. You will be registered. Then you have to create a cluster. So creating the cluster is Kubernetes cluster. You use this command to create a cluster. After having creating the cluster, then you have to run using this kube control command, you have to create a deployment in the Kubernetes cluster using this particular image that we have created, and then expose that particular deployment. So once all this is done, if you just say kube control get service, I don't know if because we are in the same project or yeah, so it is there. Okay, so you will get this URL. So you can go and once you got this URL, you have this Kubernetes service that is that's running. So you can go into this and then run that particular one, and then you can do a post predict. And yeah, model prediction you can get. So this is the second way of deployment, where what we are doing is that we have the Flask based application. First we create we dockerized it. Then we created a Kubernetes cluster manually, and then we created a service in that Kubernetes cluster. And then once the service is up, we hit that URL and then get the prediction. So this is a second way of doing it, where this is a little bit more manual than doing it in an app engine. But we dictate like how many nodes in the cluster, those things we are giving it when we are creating the cluster. So this is a little bit more granular control we have. So the third way is to do using Vertex AI pipelines. But before we talk about that, we will just briefly discuss about MLOps, and then we will get into that. Okay. So there is this paper, Hidden Technical Debt in Machine Learning Systems, which I highly recommend. This is a very old paper. I mean that it's almost like 10 years back this paper came. So they had listed out like what are the problems in machine learning systems. Like there is always a problem like you have you are able to demo your machine learning code, or but you are not able to deploy and see the ROI, right? So why is it there is a gap between model development and model deployment? So that particular problem that many people face, they had pointed out like the basic issues, like what are the basic issues in machine learning systems. Their main contribution in this paper is that they have listed out all the possible issues that comes in machine learning systems, which incurs a lot of maintenance cost. So if you look at machine learning, if you deploy a machine learning code, your model code is like only a very small, small percentage of the code. But you also have a lot of glue code you have to develop to connect your model, and then you have to serve the model, and then you also have to have some glue code to do the ingestion. So the ML code is very small, but there's a lot of additional code that are required. And so this and if you just primarily split these as separate modules and then ask separate teams to work on this, there is a problem, because like all of this is very much interconnected. So it's all entangled. So suppose that if a particular data set is changed even a little bit, you might have a like very drastically different model predictions. Even you might have failures also. And if you want to make a small change, right? So suppose that you have 10 features and you want to add one additional feature to your model. So one addition of that one feature can change the whole feature importance. It's a totally different model, and the model can start behaving totally differently. So incremental changes that you want to add, it's not very easy to change. Once you introduce some kind of change like that, it requires that you change everything. Okay, so that is what these people have pointed out, saying that it's for maintaining a machine learning model. There's a lot of costs that are involved. And so there is they have also like listed out other problems, like suppose that you have a parameter hyperparameter configuration, and if that is not that is not noted down, so it is very difficult to get a reusable result, a reusable pipeline and a reproducible result. And you have problems like drift bias, and the model can degrade accuracy. So it's a old paper. So those problems that they have listed out, model drift, and those things can happen. So because of these problems that we have to solve these problems, right? So how these issues are actually solved is having a robust MLOps. So your MLOps should have that maturity in such a way that it reduces this ongoing maintenance cost. And for each of the problem that we just mentioned in the previous slide, we can have a solution. Like for example, suppose that you make your pipelines very modular, and each of them is running in a separate container, and you have a pipeline orchestration. Then you also version your code, the data, and your model, and you have a way to track these things, like for this version of data and this version of the code. So you're getting this result, this result. So those things have to be like tracked, like experimental tracking. You have to add versioning for data, code, and model. You need a pipeline orchestration. You need all this configuration saved, like code, with all these configurations. You have to maintain them like you maintain code. So all the logging and everything. So model monitoring dashboards. So all of this you need to add to have a robust MLOps solution. So this MLOps, they say both. This is from the Microsoft link, where they say that this MLOps maturity is basically a maturity in the platform, as well as a maturity in process. So initially, in this particular Microsoft link, they say five different levels of maturity, where the highest level of maturity is when your whole machine learning life cycle is completely automated. I will also say how that is. So this is the link from GCP link, where they say they have three levels of model MLOps maturity, where they say that in the MLOps level 0, nothing is automated. So you have separate teams, and one team is doing manual experimentation steps, and they give a trained model. And then there is another team that comes in, and they do the model MLOps, and then they do the prediction, like this. So it's all separate teams. And so that nothing is automated here. So this they say is MLOps level 0. Here you can here you can see that anticipate many problems here. For example, the model that is trained by the data scientist and the model that is deployed on the by the MLOps engineer, they might be different if the source pipeline is changed, right? So they might have one version. These people can be doing it at a different version. So these kinds of problems can happen. That is why they say that at level 1, what you need is you have to have automated data and model validation steps. So it is basically introducing more automation into this. So here what they do is that here you have here again your data scientist is doing the experimentation here. And instead of using his own data sources, there is a common data source called feature store that he's using, which is used by both the data scientist and also the deployment, the deployment by the MLOps engineer. So in this case, because your data source is same, there won't be any training serving skew, and there won't be any problems or errors that can happen, because the two data sources are different. And also you have automated training. Training, you try to automate this training. So if suppose you monitor, and then if you observe that there is a issue, then you trigger a automated training. So in this level one, you have some amount of automation. You have things like feature stores, but still there is a gulf between, say, data science and MLOps. So that this is at level one. Level two, this is the highest level that they talk about, is the whole pipeline is automated. So it is like you created your training pipeline, and then the training pipeline, when it is getting deployed also, it is automated. So there is an automated deployment. So and the performance monitoring is again, like, everything, this whole pipeline is automated. So this requires a continuous integration, continuous deployment, and you also need all the additional things for the robust MLOps. Okay, so there are few. So these are directly available in GCP. So I still, not many people go for this CI/CD process. Not many companies go for it. They, whatever they are comfortable with, they go with their own level of maturity. But you can see that when you have a complete CI/CD pipeline like this, where everything is automated, then your maintenance cost will definitely come down, and your errors due to in machine learning deployment will also come down. Okay, so this robust MLOps, it requires a lot of components, like, you need feature store that talked about experimental tracking, and you need triggers to like build triggers. You need Vertex AI pipelines. All these additional steps are needed for doing this MLOps, and Vertex AI provides all these additional things. So that is where Vertex AI comes. So we will see, like, for each of this, like, what are the offerings that our Vertex AI is providing. So first is the Vertex AI pipeline, where your host, like, the for each of this, the training pre-processing, you can put it like a pipeline, and you can deploy them in the GCP as a pipeline. So Vertex AI supports two different types of pipelines: Kubeflow and TensorFlow. So we will just see, there are also open source tools available, but like Airflow, so it does the same pipeline automation thing. But the advantage is, with Vertex AI, is that it's all like unified. So your Vertex AI pipeline can write to ML metadata. It can write to, say, it can push your model to model registry. We will just look at some code here. So this is an example using the Kubeflow pipeline and Vertex AI pipeline, which underneath uses a Kubeflow. So here, when you see you are using this decorator here. So what this says is that this particular function, it will be like dockerized with this base image. Okay, so when you are orchestrating the pipeline, it will be like this, where you have all these tasks, pre-processed task, which takes an input, and it is going to write some output, and your training task is going to take the outputs of the pre-processed task, and your evaluation task is going to take the output of the previous step. And finally, you are registering this model. So now here in this, you have pre-process, train, evaluate, registering the model. But you can keep going, like, you can add on inference task to it. You can add on model monitoring task to it. Everything you can add, you can keep adding to this, so that you can, in the end, you will have a pipeline that, like this this whole pipeline, you can keep adding continuously. I mean, add them as pipelines. So that is the Vertex AI pipelines, which helps us to, like, helps us to write it in a modular fashion, and each of them will be like deployed in as a separate Docker containers, and how Dockerizing it and everything, the Vertex AI will do it for us. So if you are creating a Vertex AI pipeline, you can try this out. Example, try you can run this command, and then it is going to deploy all of your Vertex AI pipeline application that we develop. Okay, so that's Vertex AI pipelines. Then you have Vertex AI feature store. Like I mentioned, feature store is useful for us so that you can avoid the training serving queue, where you are basically using the same features that we used in training and use them in the inference as well. And it is very useful because you can share features between teams, and you can be confident about like because your data is like very well tested. You can be confident about the model output as well. So Vertex AI has a way to create feature store. There are also some open source tools also available. This Feast is again from Google, which is also an open source one. Then you have Vertex AI experiments. Vertex AI experiment is when you want to understand, like for this particular code, this particular version of the data, what are the metrics that we had. So this information is and one experiment output. So this experiment output, for tracking purposes, you need to write it to like a backend storage. So this is going to be helpful for us when you want reproducible pipelines. So you will be able to say that, okay, if I want to get the similar result, suppose that something happened and you want to roll back, and you want to go to a certain version. Now you can roll back both. You have to roll back both the three things: code, data, and your model, right? So all of the three things that you have to roll back, and you already know like what is the experimental output you got from the experimental tracking. So Vertex AI gives a experimental tracking feature. So I'm just going to quickly show how it is done. So here, yeah, you can run this notebook. So basically, what you do is that you have the parameters, batch size, everything, and you log those parameters. It is like ML flow. If you have used ML flow, it is similar to that. But yeah, so you, for every experiment, like you say what is the current experiment, and then you log all these details, like and you also log all the metrics, model output metrics. And you can access this, what is the experiment output, like this. You will have a run name, run type, and what is the parameters that you used. All of this you can keep logging it. So this is the Vertex AI experiments. Then you have Vertex AI endpoint. So we talked about deployment, right? So when we talked about deployment, we had created on Flask application and then exposed an endpoint. So it is not actually needed to do that. Like we can also, like with a few clicks, we can upload the model and then expose an endpoint. So that is also possible. So it is useful for us to, for online prediction, if you want to do this Vertex AI endpoints is very useful. The advantage with Vertex AI endpoints is that it is also inherently scalable. So this particular API endpoint that you exposed, it will do auto scaling, and you can also have one endpoint and then have multiple models behind that. So that is also possible. So I have another notebook to do that. How to deploy, how to do the Vertex AI endpoint. So you can do either from the command line, or you can run this command like gcloud AI models upload and then endpoint create. With these two commands, you should be able to create an endpoint that is like scalable, inherently scalable. So that is the Vertex AI endpoints. Then Vertex AI model monitoring. Vertex AI by default comes up with some tools for us to look into the performance, CPU, GPU utilization, and you can also look at like the data drift and everything. So the Vertex AI model monitoring is one. I think we are running out of time, so let me quickly go through the rest of it. So you can also Vertex AI gives us way to version the code, model, and data. So you have model registry and dataset registry. So you can register your model, and it will have an ID for you to refer to. Similarly, a dataset also, you have dataset registry, and you also have model ML metadata, like track the pipeline artifacts, and what we just saw, the experiments, right? The experimental output, that those metadata can be stored in Vertex AI backend. So all of this are you can do this so that you can do the tracking. So yeah, so so all of this is useful for us to tracking. And finally, you have cloud build, where you can cloud build is when you can define triggers for your pipeline. So suppose that suppose that you have modified the code and then you pushed your code into GitHub. Then cloud build can be configured such a way that once somebody is having a new check-in, then you can trigger a pipeline so that it automatically does the build. It will automatically deploy it, and once the deployment is done, it is automatically logging in all the performance metrics for monitoring. And these performance metrics, again, automatically it can look for drift and other things. If suppose the drift is happening, then it can trigger auto model retraining automatically. So all of this can be done. So this is the continuous integration and CD MLOps, which is facilitated by the cloud build. So there are a few examples here that I have shared, which you can try it from your side. Okay. So finally, we have, I'll talk about a little bit about LLM deployment. LLM deployment is, again, you can either have a pre-trained LLM and directly call the API, or the pre-trained LLM and then deploy it like what we did with Kubernetes. Or you can, now Hugging Face has got features so that you can deploy directly from Hugging Face. So there are multiple ways for you to deploy. So there is one way I have just given an example in this slide. So where we are deploying an LLM using a Kubernetes service. So that's something that you can try it from your end. So when we use LLMs, we have it's a different game compared to MLOps, because the pipeline is different. For a machine learning pipeline, you have data ingestion, feature engineering, model training. But for the pipeline stages which you will use for LLMs, LLM will be like different. You will have so it requires a totally different it requires a different approach. So that is why we are now having the LLM ops, where the evaluation and the triggers and the training. So all of this, they have a different kind of pipeline, and yeah, so that's a new thing that's coming up, LLM ops. Okay, with that, I will just wrap my presentation. We have only 2 more minutes. So you can keep in touch with me. This is my LinkedIn contact. So I'll just look at if there are any questions.